All right, in this video, we're going to talk about the second part of 8.4, so actually starting to solve these triangles. The last video, we left off by setting up these proportions for sine, cosine, and tangent. So now we're going to be using these trig ratios to actually solve for the missing sides, okay? So we're solving for the missing variables here, and I have, for number 6 here, two variables. I have the variable s and I have the variable r. So now that I have my three trig ratios set up, I have to decide which ones I'm going to use to solve for these variables. When I look at sine as my option, I have both s and r on there. It's not helpful to have two different variables in an equation. I cannot solve for either variable using that one, okay? Here, for cosine of 36, I do have only one variable, and that's exactly what I need. I need to find one variable at a time. So I'm going to take this to kind of have more space here, and we're going to set up cosine of 36 equals 4 over r. Now, in order for me to solve this, I need to do some cross multiplication. Technically, cosine of 36 is divided by 1. So if I were to cross multiply 4 times 1, I get 4. And when I multiply r times cosine of 36, I just get r times cosine of 36. Now think about what it means to solve for a variable. It means that you're going to get it all by itself. So because r and cosine of 36 are being multiplied, I can simply divide both sides by 36 so that I can cancel out, by cosine of 36, sorry. So I can cancel out that, and it's going to give me just r by itself. Okay, so right now what we're going to be entering in the calculator is this exactly as we see it: 4, then the division symbol, then cosine of 36. Again, make sure you're in degrees mode. And we are just going to round to the nearest whole number. So when I enter this in the calculator, I'm going to get a decimal. Let's see here. I get 4.94 when I enter that in the calculator. But I want you to just round to the nearest whole number. So, I mean, if you leave it as 4.94, that's fine. Or rounded, that would just be r equals 5, okay? So either of those options is fine. So I have found one of the variables, and I'm going to follow the same process to solve for the second variable. And the second variable is going to be s. And when I look at tangent, that's the one I'm going to use for solve for s, because that's the equation that only has s in it. So again, I'm going to set up tangent of 36, technically over 1, equals s over 4. And to solve for this one, I'm going to cross multiply. S times 1 is just s, and then tangent of 36 times 4 is 4 times tangent of 36. So this one's nice because I just have to put that in my calculator, 4 times tangent of 36, and I end up with 2.9. Or if you round, you could also just say 3. So just usually in the instructions, we're going to tell you how to round if needed before these, either 4.9 or 5 for the first one, and 2.9 or 3 for the letter S. So that's how we use these proportions to solve for the missing variables. So now, if I were to go back to my picture, I can actually replace this value and say, oh, s really is 3 if I'm using the rounded option. R is really 5. And soon here we're going to ask you to solve the whole triangle. And by solve the whole triangle, I mean find all the missing sides, all the missing angles. So then you could also actually find the missing angle in this case, which would be 54 degrees. I found that because all triangles add up to 180 degrees for their angles inside the triangle, okay? So that's what it means to solve a triangle. Going on to 7, I'm going to do the same thing. I'm trying to solve for my two missing variables. My first variable that I don't know is x, and the other one is y. So there's one of these trig ratios that's not going to work out, and that's going to be cosine, because cosine is using both x's and y's. I only want to take it one variable at a time. Okay, so for x, I'm just going to use the sine of 22. Remember, this is technically divided by 1. So when I cross multiply these, I get 1 times 6 is 6 equals, and then x times sine of 22. In order to get x by itself, I'm going to divide both sides by sine of 22. Okay, cancels out here. So then what I'm entering in my calculator is 6 divided by sine of 22. Okay, so unless it specifies, you can round or leave it as the first decimal. So this one's 16.02 if we round that one, or you can just say x equals 16. Okay, that's perfectly fine. And I'm going to do the same thing for tangent. So for tangent, again, that's over 1. So when I cross multiply, I get 6 equals tangent of 22 times y. You can put the y here or in the front. Then we're going to divide both sides by tangent of 22. And you are entering 6 divided by tangent of 22 into your calculator. Okay, so that comes out to be like 14.85. So y equals that, or you can round up and get 15. Okay, and that would be your answer. So this is how you would find those for x and y, and again, you can go back and put your answers up here. So x is actually 16 and y is actually 15, and we could solve for the missing angle technically because all the triangles, angles in the triangle add up to 180, so that would be 68 degrees. Okay. All right, now we're gonna go on to some word problems and applying this. In this case, we have a fitness trainer sets the incline on a treadmill to 7 degrees. So here's my incline. Let's pretend we're standing here. And we are looking for how far away the treadmill is from the floor. So we're looking for y. Now, it's asking me to approximate how many inches. So I have to keep that in mind when looking at my units. In this case right now, this says 5 feet. So I have to turn that into inches by multiplying by 12 because there's 12 inches in a foot. That means that 5 feet is the same as 60 inches. So if I'm standing there, this is my opposite, this is my hypotenuse, and I need to think about SOHCAHTOA and see which one I'm going to use. All right, so I'm looking for something with O and H in it, so I'm going to actually use the SO part, which means I'm going to set up sine of my angle, 7 degrees, equals opposite over my hypotenuse, and remember to use your 60 inches instead of your 5 feet so that when you find the answer, it's already in inches. Okay, so when I go ahead and do that, I'm going to cross multiply. Y times 1 is y, and then I'm going to do 60 times sine of 7. And then when I enter that into my calculator, I should get y equals 7.3 inches. Okay, so these word problems, it just helps if you draw a picture. Thankfully, in this one, they already gave me a picture. For number 9, I have a person standing at ground level with the base of the Empire State Building. So I'm going to draw my building, and I have my person. Probably not proportional to the building, but we have an angle formed from the ground and a line segment to the top of the building. Oh, let's try that again. From the building down to the ground. This creates an angle of 57.1. And then it says that the building is 1,384 feet. This may not actually be accurate. We just come up with numbers, okay? I want to know how far away the person is standing from the base of the Empire State Building. So I'm looking here for x. Using this picture, this is opposite to me. This is adjacent to me. So when I think of SOHCAHTOA, think of which part uses O and A, okay? So that's TOA. We're going to be using tangent of 57.1 equals opposite over adjacent. From here, you're just going to cross multiply. So 1 times 1384 equals x times tangent of 57.1. Then we divide both sides by tangent of 57.1. And that's going to get x by itself on the right. So I need to enter all of this into my calculator right now. And when I do that, I'm going to round to the nearest foot. And my answer comes out to be 895. And that's feet. So this person is standing 895 feet from the building. Okay? All right, so up to this point, we've been using the trig ratios to solve for missing sides, but we can also use them, and a variation of them, to find the missing angle, okay? And these are called inverse trig ratios. And inverse trig ratios look like this. They have sine to the -1, cosine to the -1, tangent to the -1. So we're going to be using inverse when we need to find angle measures. Okay, so we're going to be using the inverse when we're looking for the angles. So let's see what that looks like here. We have, in this picture, we're looking for the measure of angle P. And if I'm standing at P, I'm still going to label this exactly as I would. This is still the hypotenuse, this is still the opposite, and this is still the adjacent. So looking at the pieces of information I know the adjacent, and I know the hypotenuse. Thinking about SOHCAHTOA, which one gives me A and H? That's cosine. So I really am looking for cosine of angle P equals 13/19. So first I set up my ratio just like I've been doing, but then to find the angle, and when you're looking for an angle every single time, you're going to apply this inverse to it. So on your calculator, you should be finding the second button and then the cosine button, and then you should see that. And then when you enter it as 13 division 19, I'm going to go with 46.8 degrees. So you just found the measure of angle P, 46.8 degrees. Okay, and I'm running to the nearest tenth because that's what it's asking me to do. So we're going to do the same thing with number 2. Now I'm at angle D here. This is opposite. This is hypotenuse. Which part of SOHCAHTOA uses O and H? And hopefully you're thinking sine. So again, we are looking for sine of angle D equals opposite over hypotenuse. Oops. And because I'm looking for the angle measurement, that's my hint that I'm using this one instead. Okay, so when I type that into my calculator, I get 44.1 degrees. Okay. So what does it mean to solve a right triangle? Anytime we ask you to solve a right triangle, it means to find the measures of all the sides and all the angles. Okay, so we're going to be using the Pythagorean theorem, which we already talked about in an earlier section, and any inverse trig ratios, which we just did to find those missing sides, okay? So looking at this example, when we're looking for the missing side, in this case is the hypotenuse, we're going to use a squared plus b squared equals c squared. Okay, so it doesn't really matter which one you call a or b. A squared plus 7 squared equals c squared. I'm going to simplify this. And when I take the square root in my calculator, I get 8.06. So we just found the missing side. Now, we don't have any more missing sides. All we have is missing angles. This one I know already is a 90-degree angle. That's because I need it to be a 90 in order for me to use the Pythagorean theorem. But now I have to use trig ratios to find my missing angles. So let's say I was looking for angle A. I'm going to be using the opposite and the adjacent to use the inverse trig ratio to find the missing angle. So in SOHCAHTOA, tangent is the one that uses opposite and adjacent. So to find the tangent of angle A, I would do 4/7. And because I'm looking for the angle measurement, that's how I know I'm going to use the inverse. So in this case, angle A comes out to be about 30 degrees. Okay. Now from here, let me go ahead and label that. Angle A is 30 degrees. From here, you don't have to do another trig ratio. You can just use your knowledge about triangles and how they add up to 180. So then think about what's 180 minus the 90 I knew minus the 30 I just found. That means angle B is going to be 60 degrees. Okay, and there you've done it. You found all the missing angles, you found all the missing sides, and you are done. That's what it means to solve a triangle. Find what you're missing. Okay, So the rest of this packet is just going to be some additional practice. I'm going to give you some hints and we're going to do a few together. But you should just use your notes to go ahead and complete this for practice. When we are expressing the ratio as a fraction and as a decimal, we don't really need to do it to a decimal. We're just going to do it as a fraction. So for example here, to do number 1 together, if I was doing sine of A, this would be my opposite, my adjacent, and my hypotenuse. So I know that sine is so opposite over hypotenuse. In this case, my opposite is 16, my hypotenuse is 20, and I'm done. So just setting up that fraction is what we're looking for in the first 6 examples. Same thing with number 7 and 8. 7 for these 2 triangles, we're looking for the trig ratios for L and J. So sine of L, cosine of L, tangent of L, and then same thing but switching to the J, sine of J, cosine of J, tangent of J, and these are going to be fractions. So think about SOHCAHTOA. What is sine of L is 3 over 5, and so on. Okay, that's what you're going to do for those 2. For these, we are going to round to the nearest hundredth. Solving, sorry, these numbers look funky. Just, oops, ignore that. So solve for the missing variable. Let's just do number 8 together. So if I'm using the angle 52, this is opposite and this is adjacent. So think about SOHCAHTOA. That means we're using tangent of 52 of the angle equals opposite over adjacent. I'm going to cross multiply and then just enter this into my calculator. When I do that, I get x equals 16 point, let's go with 6. Oh, it says to the nearest hundred, so we're going to go 6,4, and that would be my answer. So just label your triangle based on whatever angle you're given, like OAH, and then go back and say, okay, which ones do I have? A and H. For the number 13, I would use cosine, for example. Okay. So that's these 6 problems, just finding the missing side. For the next 3 problems, we're finding the missing angle. Anytime you're finding the angle, that means use the inverse, right? So here, I'm finding angle X, so I'm going to draw my angle here. If I'm finding angle X, this is my hypotenuse, this is my adjacent. So what uses A and H? So SOHCAHTOA, so cosine. Cosine of X equals adjacent over hypotenuse. And because I'm finding the angle, that's when I know I have to use the inverse. Okay, which comes out to 56.25 degrees. Okay, and you're going to do that for these 6. So for the first 3, you're going to use the X angle. For the next 3, you're going to find T for all of those. Okay, and then lastly, 20 and 21. We're going to make 21 a challenge problem if you want to go ahead and do it, just because these require a little bit more work. In this case, remember when I said solving for a right triangle means finding all the missing angles and missing sides. So in this case, I would find the missing angle by subtracting from 180. So angle W comes out to be 33 degrees. And then I just have to find the missing side. So this would be my opposite and my adjacent. We're going to need to set up different trig ratios to find these. So let's say I want to find, we have to use, the hypotenuse, because the other one we don't know the adjacent. So first I'm going to use whatever uses hypotenuse and opposite. So that's sine of 57 equals opposite. I'm just going to call that XW over hypotenuse, cross multiply, and we get XW equals 9.8. And I'm going to do the same thing, but for XZ, but this time with cosine, because that's what the adjacent would be. Cosine of 57 equals XZ over the hypotenuse, cross multiply, and I get 15.1. So now that I found all my missing sides and all my missing angles, that's how I would solve a right triangle, by missing all the missing parts, okay? So I'm going to try 21 as a challenge, and this is the end of our notes for this section.